Hi guys, welcome back to my new video. Almost after 3-4 months, I'm coming back to with making a video. So today the new subjects we will be discussing about two subjects. We'll be discussing later on about Internet of Things, that is IoT, and we're discussing now in this video about the storage area network. The topic of the storage area network is intelligent storage system. It will come in the module two within the chapter 2 or 3. So we'll go through further in intelligent storage systems. The first topic is components of storage systems. Intelligent storage systems are feature-rich RAID array that provide highly optimized input or output processing capabilities. You'll be knowing this topic because you already written the internal for this topic that provide highly optimized input or output processing capabilities. These storage systems are configured with a large amount of memory and multiple input or output. Sorry guys for the interruption. Let's continue our topic. So these storage systems are configured with a large amount of memory and multiple input or output paths and use sophisticated algorithms to meet the requirements of performance sensitive applications. An intelligent storage system consists of four key components. We'll be discussing about those components in the next slide. So these are the four key components. Those are host, front end, cache, back end, and physical disk. In this, the components of only the front end, cache, back end, host will be common for every process. And through the connectivity of SAN, we are discussing about those topic only. It will be connectivity. The next topic is front end. The front end provides the interface between the storage system and the host. It consists of two components, front-end ports and controllers. A front-end has the redundant controller for high availability, and each controller contains multiple front-end ports that enable large number of hosts to connect to the intelligent system. Each front-end controller has processing logic that executes the appropriate transport protocol, which will be connected to the cache and fiber channel. We'll be calling as FC in short form, ISCI, ISCSI, and FICON for storage connections. Front end, uh, the SCSI means small computer system interface. We'll be discussing in the further slides. For the front end, controllers route data to and from cache via the internal data bus. When the cache receives the right data, the controller sends an acknowledgement message back to the host. So the second component of the four components within the intelligent storage system is the cache. Cache is semiconductor memory where data is placed temporarily to reduce the time required to service input or output request from the host. Cache improves the storage system performance by isolating hosts from the mechanical delays associated with the rotating disks. So in this, there are two cache miss and cache hit. Cache hit means if the particular request sent by the processor that to retrieve the data from least recent usage or uh, most recent usage. The data is present in those, and if it is easily retrieved, then it is called a cache hit. If you can't retrieve from the cache and we should go to the memory and retrieve, then it's cache miss because those data got deleted and replaced by another data. Rotating disk are the slowest component of an intelligent storage system. Data access on rotating disks usually takes several milliseconds because of seek time and rotational latency. We discussed this in the components which affect the disk performance. It will be having transfer rate delays, rotational latency, and all this seek time, etc. Accessing data from cache is fast and typically takes less than a millisecond. On intelligent arrays, write data is placed in cache then written to disk. Structure of cache. Cache is organized into pages, which is the smallest unit of cache allocation. The size of a cache page is configured according to the application input or output size. Cache consists of the data store and tag RAM. That data store holds the data, whereas the tag RAM tracks the location of the data in the data store with the disk. Enters in the entries in tag RAM indicate where data is tracks the location of the data in the data store and the disk. Entries in tagram indicate where data is found in cache and where the data belongs on the disk. Tagram includes a dirty bit flag, which indicates whether the data in cache has been committed to the disk. It also contains time-based information such as the time of last access, which is used to identify cache the information that has not been accessed for a long period and may be freed up. The third component, backend in the storage structure, is the backend provides an interface between cache and physical disks. It consists of two components, backend ports and backend controllers. The backend controls data transfers between cache and the physical disks. From cache, data is sent to the backend and then routed to the destination disk. Physical disks are connected to ports to the backend. The backend controller communicates with the disk while performing reads and writes and also provides additional but limited temporary data storage. The algorithms implemented on backend controllers provide error detection and correction and also RAID functionality. For high data protection and high availability, storage systems are configured with dual controllers with multiple ports. Physical disk. A physical disk stores data persistently. Physical disks are connected to the backend storage controller and provide persistent data storage. Modern intelligent storage system provides support to a variety of disk drives with the different speeds and types such as FC, SATA, SAS, and flash drives. They also support the use of a mix of flash, FC, and SATA within the same array. Types of storage systems. Previously, we discussed about the components of the storage system. The four components were front end, back end, with the between cache and final for physical is previously discussed. Now we will discuss in the types of storage system. Not so context, it's brief. An intelligent storage system is divided into following two categories: high-end storage systems, mid-range storage systems. High-end storage systems have been implemented with the active-active configuration, whereas mid-range storage systems have been implemented with active-passive configuration. The destinations between these two implementations are becoming increasingly insignificant. If we look around the high-end storage system, so as it is active-active configuration, so both host and storage array with are actively participating in the connection between the controller and host, which is connected with LUN. If we go to the mid-range storage systems, actually it's active and passive, but most of the times it will be looking for an active connection between the host and controller. Thank you.